Hello friends, in last class we have seen how to calculate track quality index, okay, and different formulas to calculate TQI. Now in this part, okay, we will take some example and we will try to calculate TQI, track quality index. Okay, so example, so shown here, you can see the example here. So here we are taking this example for a section speed of 130 kmph. You can see here 130 kmph speed, okay, and the details given was about unevenness and alignment over short chord and long chord. For unevenness, short chord, long chord, and alignment, short chord and long chord, right? So these are the things given. So we'll see. So for calculating TQI, we require TQIS and TQIL. So TQIS, we require unevenness index, alignment index over short chord, and TQIL, unevenness index and alignment index over long chord. Alright, so these are the things required. And to calculate unevenness index, we require what? M, N, NB. So this we have seen in detail in the last video about what is M, what is N. So M is what? Measured HD. This is new track HD. NB is NBML HD. Okay, these things we have seen in the last class. Now let us try to find out M, N, NB from the data given. Okay, so see here. So for unevenness they have given short chord, long chord. Okay, so N value short chord, long chord, NB value short chord, long chord, M value short chord, long chord for unevenness and alignment they have given. So from this table, if you take M, so here M value is 10 for unevenness short chord, and M value is 12 for unevenness long chord. Similarly, N value is 1.4, 1.9, NB value is 4.9, 7.4. So this data was related to unevenness short chord and long chord, and this data was related to alignment. Now by using this data we will find out what is TQI combined, right? So now let us find out. So first UNIS, so this is unevenness index over short chord, okay, so which is equal to 100 by e power m minus n by 1.3 nb minus n. So 100 divided by m value 10, 1.4, e value e power 1.3 into 4.9 minus 1.4. So e what you will take? 2.72. Okay, so after calculating you got around 17.72, right? And similarly for unevenness index or long chord, so you got m value, n value which was tabulated, and e value you already know 2.72, and n. So finally you got, okay, unevenness index over long chord as 27.02. okay, so this is short chord unevenness index, this is long chord unevenness index. So this is first thing required. Next, for alignment same way we will calculate. For alignment index over short chord, 100 by e power m minus n by 1.3 nb minus n. So in table C here, these all things related to alignment. So this is m value, this is n value, and this is nb value, right? So these things will substitute for short chord m, n, nb, n. So if you substitute, you got around 13.36. okay, right? Same way from table you have alignment long chord data 10, 1.3, 5.3. So if you substitute here in this formula, alignment or long chord is equal to 100 by e power m minus n by 1.3 what mb, right? So this is nb minus n. So after substituting you got around 21.07. Now you are ready with what? UNIS, UNIL, ALIS, ALIL. So all these things you are ready. What all things you are ready? So you see this formula. So you are ready with this value, this value, this value, this value, right? So now you can easily calculate this one, TQIS and TQIL, right? Once you know TQIS, TQIL, you can calculate TQIC. So that's what I have done. So here, so here TQIS, now I am calculating TQIS. So this is TQI using shortcut. So UNIS ALIS divided by 2. So 17.72 plus 33.64 by 2. So which is equal to 25.68. So you got track quality index over shortcut. And TQIL, so similarly this is based on long chord, this is based on long chord, and by 2 you got around 24.05. Now if you know this and this, you can calculate TQIC, so which is equal to TQIS plus TQIL by 2, so which is equal to 24.86, right? So this how we will calculate track quality index combined. So one thing you have to remember, the short chord was helpful for speed less than or equal to 100 kmph. So where speed is below 100 kmph, we go for short chord, and when speed is above 100 kmph, we go for long chord. Okay, when speed is less than 100 kmph, we go for short chord, and when speed is greater than 100 kmph, go for long chord. But generally what was taken for short chord, we use for lesser speed, 100 kmph speed, we will use short chord, and for higher speed more than 100 we will use combined, this TQIC, which is a function of both short and long chord. So that's what we'll do, right? I hope all the concepts was very clear to you. So overall what we have seen, so in part 1 we have seen basic things. SD, what is SD, how to calculate SD. Nominal gauge means 1676 gauge, okay, that we have seen, right? Next we also seen what is mean gauge. Mean means suppose you have a block like this 200 meters, right? So now what will happen, now TRC start recording gauge at each and every location, right? So average of all these gauge values is called mean gauge, right? Peak means you already seen highest value, right? So all these basic things we have seen here, right? We also see in SD means what, SD means with respect to mean how data is varying, right? With respect to this is mean, how data is varying over this mean value, so that is standard deviation, right? Next how to collect track parameters. So this thing we have seen in part 2. So yeah, we have seen about what is short chord, what is long chord, right? So for unevenness, 9 meters is short chord, and how to find out unevenness by using this chord length, right? Those things we have seen in track parameter calculation. Also we have seen how TRC record the data, okay. Next in part 3, deep understanding, so we have discussed all formulas related to TQI, right? And in part 4, this portion we have discussed about calculation using an example, right? We have taken some example and we have discussed how to calculate, right? Okay, thank you friends, thank you for watching. Okay, please subscribe and share to your friends. Thank you so much.